Hello, my name is Miss Sarah, and I'm a new Youth Services Assistant at the Samuels Public Library. I haven't had the chance to meet many of you, and I'm looking forward to doing so when the library reopens. But for the time being, I would like to go on an adventure with you this summer in a Symphony of Sounds as part of the Dig into Reading summer reading program. Sound is very important. It's all over our planet. It impacts our environment, our culture, art, the way that we think even. Anything you can think of, for the most part, sound has something to do with. So I'm really excited to get started on these with you and learn new things myself along with you side by side. We're going to be going over all sorts of musical instruments, as well as many science sounds that occur in nature, as well as the way that we process sound, the way that we think about sound, and the way that music makes us feel, as well as sounds. So for today, I would like to talk to you about vibrations, pitch, and sound waves. The main goal of today's program is to answer your questions about how you can understand sound and where it comes from in the first place. I would like to point out that for today's program, I'm going to ask some reflective questions, so I would love for you to have some paper and a pencil ready to write answers down. You can also talk about the questions with your family and friends. I would love to hear your opinions. So first of all, I have a video that can explain your questions about how you can understand sounds and where it comes from in the first place.
Take a look at this. It's our musical sound wave vibration display of science. This is an electronic keyboard, and this is a piano. This is the display of an oscilloscope. It's a device that's connected to a microphone that picks up sound waves in the air and shows them to us here on the screen. When I hit a low note, we can see that the waves are pretty far apart. When I hit a high note, the waves look about the same, but they're much closer together. This is true on the electronic keyboard or on the piano. Now this is called the pitch of the sound. So this would be a low pitch sound, and this would be a high pitch sound. Now we take these sounds and arrange them in what are called notes of music. Now notes of music can be close together or far apart. That's called the rhythm of the music. How close together the notes are, and how long each note lasts. There's one more thing. We can play a note softly or loud. So, pitch, rhythm, and loudness, they're all ways to make vibrations of sound that can become notes, that can be arranged in patterns to make music. They could be arranged into patterns that become music. Depends on who's doing it, I guess.
Okay, so as Bill Nye has explained, sound is made from vibration. Vibration is just a really fast back and forth motion, and vibrations are what create sound waves. So I want you to think a bit creatively for a second. Can you think of some things that vibrate? Write some things down, maybe things that you can think of that vibrate. As for me, I can think of a couple things. I can even think of a way that you can make vibrations right now without any kind of object, just by yourself. For example, put your hand on your throat as you speak, or maybe you hum. Do you feel the vibration? That's your voice box working. Your voice box works by vibrating. There are flaps in your voice box and they vibrate really fast. And that's how we produce any kind of sound. Singing, shouting, humming, whispering, or just talking like how I am. That's how we speak. That's how we produce sound. It's all because of vibration. So going along with the theme of vibration, I have a very simple activity for you to follow at home. And all you need is a simple ruler. All you need is this, and you're going to be able to sort of visualize vibration at home. So let me show you. All you need to do is have your ruler in the edge of a desk or the edge of any kind of surface. And I'm going to put about half of it, hold half of it with my hand and put about half of it off the desk. Now here's the fun part. You just take your hand, smack it. You see that? You see how it vibrated up and down a bit and then it stopped? It also produced a sound because of the vibrations that it made that you can see visually for the most part. Doesn't last very long though, does it? It stops very fast. So here's where the experimentation comes in. I'm gonna put more of it, way more of it out. Almost the whole thing. Make sure you're holding on very tight so when you smack it, it doesn't just fly all across the room. Oh, still going. That lasted a lot longer, didn't it? The sound it made was a bit deeper. As Bill Nye was talking about, this also has to do with pitch. It made a bit of a lower sound, but we're going to get into that in just a little bit. Observe again. Look how much longer that went than the last time. But if I put almost all the way out, I have just this little bit, it's barely enough for it to vibrate. See? Higher pitch a bit, and it doesn't last nearly as long as when it was all the way out here. So I would like to invite you to try to mess around with this a bit at home and just see what happens. I want you to observe how long the vibration lasts, depending on how much you have in or out. So with us having talked about vibration, and with Bill Nye having mentioned pitch in his own video, I would also like to talk to you about pitch. So pitch is what we call the lowness or highness of a sound. This is what music is made of, as Bill Nye mentioned. Music is really just a bunch of pitches put together in a way that is supposed to be enjoyable to us. And we'll talk about emotions in music a bit next week, but our brain can process music and understands the series of pitches that happen. So to help me explain pitch, I have my friend with me. Say hello to my friend Tony. He's an automaton, and he's a little bit of a weird instrument. If you tune into my Weird Instruments program, I'm going to talk more about how he works. But Tony can produce all sorts of pitches. He can make very low pitches, and he can make very high pitches. So everybody say hi to Tony. He's saying hi to you. So first, Tony, I would like for you to make a low pitch for everybody. He makes a funny sound. So here is one of the lowest pitches that Tony can make. Oh, that's so low, isn't it? He's got such a deep voice. How about something in the middle? It's a little higher than a low pitch, but it's not very high, so. Very good, Tony. How about a high pitch, a really, really high pitch? Let's try it, see what he does. Whew! What a squeaky voice you have, Tony. So Tony can produce all sorts of noises. And as you can hear, there's low, medium, and high. It is worth noting that there are some sounds that we can't even hear. Let me just share my screen again with you guys. And I'll show you what I mean. As you can see, as presented on here, there are some sounds that we can't even hear. there is sound that is below what we can hear called infrasound, and sound that is above what we can hear called ultrasound. So of all the pitches that exist in the world, we can only hear some of them, not all of them. Infrasound, as you can see, our cats can hear sounds that are lower than what we can hear. So if you ever see your cat looking at something and you don't know what it is, it could be maybe they hear something that is in the infrasound range. And ultrasound is sound that's higher, like I said, higher than what we can hear. Our dogs can hear higher sounds than we can. They can hear ultrasound. And the picture of the dolphin and the bat refer to echolocation, which I'm going to talk about in a bit. But essentially, dolphins and bats can also hear ultrasound. So, I would like to do a short activity with you that involves Tony. So I'm going to play a set of 2 pitches, and I would like for you to write down which pitch was lower and which pitch was higher. So for example, I think the first pitch was lower and the second pitch was higher. So I'm going to do 3 of these. Here's my first one. All right, Tony, work your magic. So is the first one. How about a second one? That one was a little challenging, right? Let me play it again. Maybe a third one. So feel free to go back and watch those again if you weren't able to catch them the first time. So I would like to challenge you. I think that you're probably getting really good at this, and I would like to challenge you. And don't worry if you don't get it, but I want to see if you can. And no matter what, know that I'm proud of you. You're learning so much. You've already learned so much in this program. I'm going to play a series of 3 pitches instead of just 2. And I would like for you to tell me which one was the lowest, which one was in the middle, and which one was highest. So you can tell me the first pitch was in the middle, the second pitch was lowest, and the third pitch was highest, or whatever it ends up being. So here we go. I'll play again. All right, I think we've had enough of you for today, Tony, but don't worry, Tony's gonna be back. He's gonna help me with a lot of other programs as well. So now that we've talked about vibration and pitch, that brings us to sound waves. And I'm going to share my screen with you again so you can see the things that I've discovered for you. So, as you can see here in the picture, sound waves are a way that we can visualize what sound looks like. When a vibration happens, it makes a sound wave. It can travel through air, water, and solids. Although you can't see sound waves with your own eyes, there are special machines like the one that Bill Nye used that can help you see them. The size and shape of the sound wave determine what kind of sound it is. As this picture shows, the height of a sound wave determines how high or low the volume is. If a sound wave is super tall, the volume is going to be very loud. If a sound wave is very short, the volume is going to be very quiet. The pitch of a sound wave can be determined by how many wave crests there are, or how many times you can see waves occur. If there are a lot of wave crests, then the pitch is high. If there are not a lot of wave crests, the pitch is low. Also, the smoothness of the sound wave shows how noisy or pure the sound is. So a loud crashing noise, like cymbals crashing together, is going to produce a very messy, jagged sound, while a gentle ocean wave will produce a smoother sound wave. A very harsh noise, a very harsh abrasive noise, looks very sharp, while a very smooth noise looks round. So, with this being said, let's do another short activity together. Here I have 2 boxes, and they each have sound waves in them. Let's look at box 1 first. Make sure you have your paper and pencil ready. Using what you've learned already, can you guess what kind of sound each wave is going to make? For example, let's first look at sound waves 1 and 2. Which sound wave is pure and which one is noisy? Let's look at sound wave 3 and 4. Which sound is loud and which sound is soft? Do the sound waves have high or low pitches? Hint, both have the same kind of pitch, so both of them are either high or low. Lastly, let's look at sound waves 5 and 6. Which sound is loud and which one is soft? Do the sound waves have high or low pitches? And again, as a hint, both have the same kind of pitch, so they're either high or low. Now, with that being said, let's look at box 2. Each wave is either smooth or harsh. Which sound wave is the smoothest and which sound wave is the harshest? What do you think? Now that I've given you a minute, let's look at the answers. Let's reveal. Abracadabra. Here we go. How did you do? I bet you did awesome. You should be proud of yourself. You're learning so much, and you're learning so much about sound waves. It's awesome. So I'll stop sharing because I would like to show you another craft for you. And actually, I'm going to share one more time to show you the materials that you're going to need for this craft. All right, so although you can't see sound waves, really, there's a way that you can sort of visualize what sound waves would look like. And all you need at home are some very, very simple household items. So first of all, you need a simple cereal bowl or mixing bowl, cling wrap or saran wrap, a 1/4 teaspoon of sugar, salt, or sand, and things to make noise with. For example, you can use your voice, hum, speak, shout, just make some kind of noise. You can bang a metal spoon on a metal baking pan. You can use a noisemaker or a party blower, a musical instrument like Tony, or you can do all sorts of things. Just make some sort of noise. So with that being said, I would like to try to do my own demonstration just to see how it works out for me, but I would like to know how it works out for you at home as well. So here I have my bowl, which has cling wrap on it, which I've hopefully I have pulled it tight. You need to pull the cling wrap really tight over the top. So it's just like a drum head. And I have my 1/4 teaspoon of, I'm using sugar, but you can use salt or sand. Just going to pour that on the top. And first of all, you might just hold it. If you feel like it's not tight enough, you can hold it with your hands as well. I'm just going to hum really close to it. It's not exactly the most active because my voice is not very loud when I hum. So I saw a couple of the grains move a little bit, but nothing very significant. So one other thing I can do, a louder sound I can make. I have an aluminum foil, baking sheet, and a spoon. Let's see what happens if I do this. Did you see that? Some of the ones around the edge were moving a bit. Maybe at home when you do this, a way it could work better is if you spread it out a little more. Certainly that was more active. So when you do it at home, make sure to spread it out a bit so you don't run into the same problem that I did. So as a bonus, I would like to talk to you some about echolocation, a special way that sound waves can be manipulated by certain animals and by submarines. So let me share my screen with you one more time to show you one more picture that I found that is really interesting. So certain animals, as well as, like I said, submarines, can use echolocation, or in the case of submarines, it's called sonar. Some animals, like bats and dolphins, use sound to tell where something is located. Submarines, like I said, can use this too. When a sound wave hits a solid object, the sound partially bounces off of it, and that makes it easier for the animal to locate it. To explain further and see it in action, I also have a really fun video about bats that I can show you. It's all about how bats find their food.
High on the rocky cave ceiling above me, hidden in the darkness, there are vast numbers of bats. You can get some idea of how many there must be because of this huge dune behind me. That's formed of their droppings. And if you see little moving glints on the surface, that comes from an army of cockroaches which are chewing their way through the bat droppings to extract the last particles of nutriment. Some people think there are 1 million bats up here in this cave. It's impossible to see them in the gloom. But special night vision cameras can reveal them. Densely packed crowds hanging from the ceiling. Their tiny eyes are adapted to low light, but they cannot penetrate the blackness. Millions of years ago, however, these bats evolved an extraordinary guidance system known as echolocation, or sonar. A bat produces extremely high-pitched sounds in its throat and then projects them forward. We have slowed the sounds down, but can still only hear them by converting them to lower frequencies. They bounce off the walls as echoes and are detected by the bat's huge ears. These are in constant movement and enable the bat to map its surroundings with remarkable precision.
Okay. So that is actually all that I have for you today. Although I think you've learned so much, and I'm very proud of you, and I'm very excited that you've tuned in with me. Next week, we're going to be looking at the psychology of sound, how sound makes us feel, why we like and dislike certain sounds, and how music makes us feel certain emotions. So I really hope that you tune in with me next time, and I'm really looking forward to getting to talk with you again. Bye!